Hello. Yeah. So, good evening, everyone. I hope everyone is present here, and so we can start now. So today we are going to discuss about statistical functions as it was scheduled for the fourth session, and today we will look into some real data of shares, share prices, and we will try to analyze them statistically. So, so that will help us to understand the statistic analysis on Excel in a better way. So here, let me show you that how I downloaded these data. Let me show you first that how I downloaded this data from internet from Yahoo Finance, which anyone can easily do. So, so here I am on Yahoo Finance page. Uh, yeah, so somebody's audio was on. Yeah, so let's begin now. So this is Yahoo Finance page, and here I put, suppose I want the ITC share prices, historical price. So I'm just going to open that page, and here is historical data, and I want the data for last 5 years. So it's already selected, last 5 years, and then apply, and then we can download this data. So data will be something like this. Not this one, it's open. Yeah, this. So we will be having here the share, the date of the share prices. So we have date starting from 13th of April 2015 till the last working day, till the last session of the, of the market. That is 9th April 2020. This was the last, uh, you know, um, working day of for the trading. Okay, so we have the prices of share for these 5 years, and then opening price is basically the price at which the market start, and high price is the day high, whatever high it reached during the day, and then there's low price, that the price of particular share in that trading session, 1 day trading session, what was the lowest price which it touched, and close price is when finally the market closes, what price it stopped at. Okay, and then there's adjusted closing price. So I'm using a adjusted closing price, which means that in case if the share is, if any share got split, for example, I remember last share which I remember got splitting was HDFC. Before splitting, the HDFC was, I think, for 2000 rupees it was trading, and after splitting into two halves, the share price become 1000. Just think, a day back the price was 2000, and a day later it become 1000. So basically, if it will not be adjusted, then it will show a loss of 50% from 2000 to 1000, but it's not actually how it works. So my one share converted into two share in my demat account, my one share converted into two shares in my demat account. Okay, and the value of my shares holding is still 2000, but now one share cost me, or the price of one share is less, right? 2000 to 1000. So that's actually 50%. So that split is actually adjusted, because if we take 1000 as closing price for analysis, it means that we are recording a 50% loss, which is not actual. So that's why adjusted closing price means if the company is issuing any dividend or it is splitting its share, so adjusting price actually incorporate all those changes in the prices. That's why you can see that close price and adjusted close price is different. So that's what I did here. I copied this. So I've already copied here ITC price and Nifty. Another is Nifty 50. which represent the market portfolio. Okay, market portfolio means collection of shares, lot of shares. But in Nifty 50, there's only 50 share. But it actually represents the market. That if Nifty goes up, we assume that market is going up. If Nifty goes down, we assume that market is going down. So we are going to do statistical comparison of Nifty and ITC. So let's see how this statistical tools which we are going to learn today will help us to make this analysis. So first, let's see the price movement. But before that, we can see that there are some text. Okay, in this, for example, there's null for date of 15 for 2015. There's no data point. Maybe because of some error, or maybe that on that day the share market price isn't available. Anything can happen. So we have to remove those data. So again, we already learned how to spot these, these kind of cells and delete the entire row. So we are going to clean the data right now. So it's go to special, and after that we are going to check the constant. Under constant, we are going to look for text, and okay. So all the text has been. Let's do one thing. Select it from here. Yeah, because if I am going to select apply to hold, the heading will get deleted. So let's select it from here and then run that. So go to special, constants, and then we have to see where are the text available, and okay. So now we have selected all the text. Somewhere down also it might be, we can see it once if you want. Yeah, so here also one data point which contain text, so we don't want that. So now we will go to home and delete it. So delete sheet row. So in whichever row it is available, the entire row will get deleted. Yeah, so now we are done with data cleaning. Now we will move to analysis. First, let's see how the prices are actually moving. So insert, and we are going to bring this. So this is for Nifty because Nifty have a higher price, and this is for, so we have to change the, we are just trying to change the axis by selecting the line over there. Can go for second axis. Just a second. Okay, let's put this on another graph. I'm not able to get the another axis. So we can see this in another graph as well. Yeah, now it's active. I'm just trying to select this and it isn't getting selected. Well, we can see that on the other graph as well. So insert the another graph for this. Yeah. So we can see that for ITC and another graph for this is basically for Nifty and this is for ITC. We can see that both are them actually moving quite together in the same direction, right? The left hand side is for Nifty and this one for ITC, and we can see that both are making the same kind of movement, almost the same. It means they are moving together. But and we are going to see this is actually the price line, that how the price are moving. So we can see the sharp fall at the end. This sharp fall represent the recent fall which started by mid of February. Okay, so this sharp fall in the Nifty as well as in ITC represent the fall in mid of February till now. Almost 40% of market have been crashed, right? So that's why we can see the sharp fall. So now we have to analyze the return. So this is the price movement. What are the returns that we are able to So this is return for Nifty, and I'm going to calculate return for ITC. So I'm going to calculate the daily return. So how I will do that? Suppose on 13th of April 2015, I'm going to buy this share and sell it on 16. So what will be my profit or loss for that particular day? So I'm going to calculate it by, for example, this price minus the buy price divided by the buy price. So this is the return which I am getting for that particular day. In the same way, I'm going to calculate return for all 5 days. Similarly, I'm going to do for IR and then expand it for all 5 years. So I have returns for both. So these are actually daily return. So from this daily return, what I can calculate is average return for last 5 years. Let's calculate that. Mean, that is average return. We already know what is the formula for average return. So this is for Nifty and this is for ITC. So yeah, so these are actually not 8 and 4. These are very small number in comparison to. So I'm just going to convert it into number so that you can understand how small the daily return is. So it is almost 0. Let me expand it to some more decimal places. Yeah, so we can see that how small the return is. If I'm going to convert it into percentage, so daily return in percentage form is even very, so it's 0.009% of return we are getting average. And of course, this return is so low because of last 1.5 month fall. If we exclude that, suppose if I'm going to calculate the average for return excluding the last February, okay, so this is up till January, right? January 31st, 1, 2020. I'm just calculating the average return up till that point. So we can see there is better return as compared to, let me convert it into percentage. So there is basically 0.029% return on every day. Okay, so that is much better than the return when we are including the last 1.5 month. Okay, so this is the mean return. And after that, what we are going to look into the standard deviation. And let me explain you what a standard deviation is. Standard deviation, STDEV dot PP for population and downwards is S for sample. Okay, so we are actually including this the population formula over here and getting the standard deviation of return. So this is the standard deviation. We can convert it into percentage as well. In the same way, it's for ITC. So I use few terms over here, population and sample, and then a standard deviation. So first, let me explain what the population stands for in statistics. When suppose I want to record or calculate the average speed of all the cars in India running in India, okay. So if I'm going to, take the observation of each and every car present in India, so that observation or that collection of data is called population. But think, is it possible to take observation of each and every car? Of course, it's not, right? Because it will be very time taking as well as very expensive process. So what we will do, we will take only 200 or 300 car sample and then record their observation, and on basis of that sample we'll try to get the average speed for entire car, okay, in India. So basically sample is a subset of population, right? So when we are using population, I mean the total set of data, then we are going to use the population formula, and if we are using only selected few, then we are going to use the sample standard deviation function. Okay, now let's talk about what a standard deviation is. So as you know that I have calculated this as mean daily return, that is 0.009%, right? When you observe that this data, for example, first day return is not 0.009, it is somewhere far from 0.009, maybe in negative side, or take this example, this is in the positive side. So these are spread, okay? Some spread are towards negative, some spread towards the positive, okay? So what is the average spread? I mean, what is the, you know, possibility or volatility of positive and negative returns? That is calculated by standard deviation. Okay, so mathematically I can show you process that how we can calculate the standard deviation, but it will take a lot of time, so I'm not going to do that over here. But whenever we calculate this mathematically, first thing we reach is variance. Okay, and what this variance is, variance is basically this, sorry, the square root of standard deviation, sorry, square of standard deviation raised to power 2. So this is going to be the standard variance for this particular share. So we can calculate it through function also. We have var.p or var.s. Again, the same concept, population or sample. So we can use this function to calculate var. Let's see for this. Yeah, so we are getting the same var, right? Let me convert it into percentage. Yeah, so when we squared it, we got the same variance, and the same value we are getting through variance function. So this is VAR. We need to calculate the VAR for this. So if we are going to get the square root of VAR, again we are going to get the standard deviation. SQRT stands for square root of VAR. So we will get again the standard deviation, which is same in this case, right? Both are same. So the square of a standard deviation will give us variance, and square root of variance will give us standard deviation. Okay, so other functions which include mean, mean, medium, and mode. So we have already seen mean. Let's look for mode and median. So let's discuss what is mode. Suppose I put few numbers over here. Yeah. So if I'm going to ask you that what is the mode of this set of data? So mode means those number that has a repetition. I mean, it is repetitive many times, maybe more than one time. It can be 2, 3, 4. Okay. The maximum repetition, whichever number will have, that will be the mode. So in this case, we can see that 23 appeared for 2 times, right? So this will be the mode for this data set. So 23 is going to be mode for this data set. Similarly, we can calculate the mode, that is which return actually appeared for maximum number of time. So actually we can see that these are, you know, in many decimal places. So possibly there would be no mode at all, because numbers are going to differ by 0.001 or 0.0001. Maybe there will be no same kind of return. Sorry. So maybe there may be not same kind of return. Let's see whether the data have mode or not. Yeah, so this particular return is there twice, 3 times, whatever possible, that many numbers of time, and mode for the other ITC is going to be, yeah, so this is the mode for ITC, right? So now let's talk about median and understand what median is. Just look at the same data set which I have created just now and give them position. So say this is the first position, second, third, fourth, fifth, and sixth. Okay. So I have to sort this data either in ascending or in descending order. Okay, let's make it 7 set of data. 35. Yeah, so let's arrange it in ascending or descending order. Home, sort, sort smallest to largest, and we have to sort only that part which is selected. So we will go to continue with current selection. If expand the selection means that these entire row will get sorted according to this particular row. That's what it means, expand the selection. So we don't want to do that. We just want to sort the selected portion. So now it's selected, right? Sorted. So now we have to see which is the exact middle one, middle position. So this is an odd number. There are odd number of observation. So formula is n plus 1 by 2. So 7 plus 1 by 2, that will 4. So 4 will be exactly in between the positions between 1 to 7. So the number exactly lying in front of that will be median. So I will tell you that when we use median, when we use mean for measure of center dispersion. So let's try to see what's the median for this data set. So it's 35, right? So in the same way, we are going to calculate the median for our data set. Yeah, so this is the median for our data set. For ITC, it is this. Okay. So now, is it understood by everyone up till here? So I will just discuss the difference between or when to use mean, mode. Okay, so let's move now and understand when to use median or mean as center of measure of center of dispersion. So we use mean. For example, I am saying that mean what represent over here, that if I am going to invest in this particular share for say 1 day, 2 day, 3 day, so the average return that I am going to get is 0.009 if I'm going to invest in this share for 1 day. Okay, we can also change it into yearly return, annual return, but right now I'm not doing that. I'm just looking for daily return. So if I'm going to invest in this share for 1 day, there's high probability that I will get an average return around 0.009%, maybe a little less than that or maybe a little more than that. Okay, not, for example, in 1 day I can't say that I will get negative 10% this return, or maybe positive 10% discount in 1 day. That is very unlikely to happen. Okay, it will always be somewhere around the average. Okay, but it has a different picture as well. For example, if I am going to say that an engineer who is working in Reliance says that my average salary is say 1.2 lakh monthly. Okay, and an employee working in Apple says that he has a monthly income of 2 lakh. Okay, so definitely I'm going to look for working in Apple, right? But suppose if I'm going to include the salary what Mukesh Ambani is taking in the total salary of Reliance employees. For example, I'm just going to say that suppose that there are 10 employees in Reliance who are earning 1.2 lakh monthly. So total they are earning around how much? Total salary paid by Reliance is this much, that is 12 lakh monthly. Okay. But if I'm going to add just one more salary, and that's Mukesh Ambani, suppose he's getting 100 crores of rupees, um, that will be around 10,000, I think. Okay, let's say that if it's, sorry, one person and he 1.2 lakh per person employee, per person salary, just say that uh, Ambani is getting something around that. Maybe I think that will be 10 million. So in that case, if now we can see that the total employee is 11 and total salary which is given now is 12 plus this, right? So earlier when we see that 12 divided by total number of employees is giving us 1.2 monthly salary. Okay, but if now this is the total salary and number of employees are actually 11, the 10 normal employee and one more Mukesh Ambani salary. So that will count up to 11. So now see how the average salary went up. So if I'm going to tell Apple guy that my salary average salary is 910 lakhs of rupees, so you can understand definitely he would love to come to Reliance, but definitely he's getting fooled because this particular data set contains an outlier, that is something extremely high or extremely low from the normal set of data. So whenever there is outlier in a data set, then mean will always represent a wrong estimate. And in that case, median comes to rescue because it will not give us the average, but it will give us the positional. It means whatever median will be, 50% of the people will be earning less than that, and 50% people are earning more than the median salary. So median is a better, better estimate of central dispersion. For example, many colleges even show us average salary, but not median salary because few students, for example, in IIM, few students got a salary of 1 crore or 1.5 crore. That's only 1, 2, 3. But most of them are going to get average salary of 25 lakh to 20 lakh to 25 lakh. So average is going to go very high, but when you look for the median salary, it is going to be very low, around 20 or 22 lakh, right? So that's when this median comes into play. So I hope I made it clear what's the difference between mean and median and when to use it. Okay, so now let's move ahead. Is there any confusion till here? You can ask me by unmuting your audio. Yeah. So okay, then let's proceed then. So now we are going to look some more statistical tools. So most of the statistical tools we are going to get under data analysis. Okay, so these are the list of statistical tools that we can use. For example, ANOVA, single factor. So we are not going to discuss all of them. We are going to use very selective one because ANOVA is itself a very big topic, and using ANOVA or studying ANOVA will take another 2-3 classes, which you can learn in our statistic course as well. So we in a statistic course we explain each and every function which is over here. But yeah, right now we are going to look at some basic ones, like we have descriptive statistic, correlation, covariance, histogram, and regression. These are the functions which we are going to do right now. Let us start with descriptive statistic. So we have to select the range. Let's say we are going to, let me put it up so that we can have the headers in the same line. Yeah, so this is the data set I'm going to use, and we wanted summary statistic we want, and there's label in the first row as well. Okay, so here we have the, yeah, so here we have this two columns are for Nifty and ITC price movement, and the another this two are for the returns, daily return which we have calculated. So let's look at this because we have already calculated this. So we can see that mean are same as we have calculated. It is still in the form of E. So that's why it's showing in this way, but we can see here that in number it's very much close to 0. The daily return is, and that's again because of mostly the last 1.5 year negative 40% return. And this is the mean for ITC. Then a standard deviation is the same which we have calculated. Somebody is experiencing audio problem, I guess. Maybe there would be some net issue. Check your net connection. Yeah, so we have also calculated the median, mode, standard deviation, sample variance. Now, kurtosis and skewness, I will just explain you what these two terms are and how to calculate it even. And then range is the maximum minus minimum. We studied yesterday how to calculate the maximum value and how to calculate the minimum value. So when we subtract minimum from maximum, what we will get is the range. That will say, the range actually say what is the spread, the total spread of the data. Okay, and then minimum maximum we already know, sum and count. So left with kurtosis and skewness. So I'm quickly going to explain you that what are those two things, but not in its detail. Yeah, see, there's a term called normally distributed data. So we assume in a statistic that data are normally distributed, which seems to be something in this shape, which is called bell-shaped curve. And on this side, its frequency. I'm not able to draw the straight line, sorry. Yeah, so this is frequency and this is the data point, actual data point. Okay, so if I say that average return is 10%, okay, so if we move one standard deviation toward this side and one standard deviation towards this side, so this will have one standard deviation positive and this will have one standard deviation negative. Don't get confused if you are not getting all these things, but normally we distribute that data are normally distributed because this will help us to study the data and make prediction. Okay, that's why we assume that data are normally distributed. But sometime what happens that the shape of data gets changed and it may be like this. Okay, so in negative side there's more, data is more towards higher, I mean, for example, if this is 10% average, so extreme data are there, which I told that outlier, and that outlier actually lies in the negative side. So say it's 50% negative. So if data lies or if this data set is skewed towards left, then it's called left skewed data. Okay, that's what skewness means. If it is right skewed, something like this, it means it is right skewed. It means the positive side is higher in number, right? For example, in Japan, older people are large in number, so the the age data for that country will be right skewed. Okay, so it's something like that. Whereas when we talk about kurtosis, it means the shape of bell. So if the data can be distributed something like this, or maybe like this. Okay, so very little bump or very high bumps. So basically this shows the skewness. So just I'm trying to make you understand in terms of diagrams that what exactly skewness and kurtosis looks like. So there are functions which help us to create these things. So we can again say, so we have kurtosis for this, so we can select the data and calculate the kurtosis for this. We have in the same way we can calculate for ITC, and similarly we can go for skewness. We have a skewness function, so we can select the data and get this skewness. Okay, so now let's move ahead. So I hope this descriptive statistics are clear. And whenever we start analyzing data, we actually start with descriptive statistic because it will tell us many things about the data, that what kind of return it is providing, what are the sorry, what kind of return it is providing. Standard error is what? There's a good fit line. When we will do regression, we will understand what is good fit line. So the distance that data point have from that good fit line is actually the standard error. Okay, so we are done with descriptive statistic. Now let's move towards the correlation and covariance. Okay, so let's calculate correlation and I will explain what correlation is. Yeah, so correlation will be between two sets of data. So this is the first set and this is the second set of data. Yeah, so the correlation stands 0.54. The coefficient of correlation is always between -1 and +1. It cannot go out of this. Okay, so what does it mean? So it means that if Nifty is giving say 10% return, then is ITC is also giving positive return. So suppose if the correlation of these two would have been 1, okay, so they are perfectly correlated. It means that if Nifty is going to give 10% return, that means if market return is 10%, ITC will also produce 10% return. Okay, but this is not 1, it is somewhere 0.5. So we can say in this way that if Nifty is going to return 10%, then maybe ITC will return 5%. Okay, so there's positive correlation. Both are going to move in the same direction, but may not with the same magnitude. Okay, and for okay, so and if it will be negative correlation, suppose it would be having negative 0.54. So it means that both data are negatively correlated. It means that if one is suppose it if it would be -1, then if Nifty is giving -10% return or say plus positive 10% return, ITC will give negative 10%. So they are totally negatively correlated. Okay, yeah. So this is about correlation. We can also calculate covariance. Covariance and correlation almost suggest the same thing, whether the relationship is positive or negative. So covariance we can calculate. So there are again the array 1 and array 2. So this is the covariance, right? Now let's look some other things as well. Data and then data analysis. Histogram. Okay. So let's look this now. So when we are going to create this dialog box appear, they need input range. So if I want to create a return histogram for say Nifty, then I'm going to put that whole data, and then there's bin. Bin is basically the range of return. Okay, so we have to create that bin first before making histogram. So how we will calculate that bin actually? So we have to get the minimum data from the data set. So this is the minimum and this is the maximum. Yeah, so we are going to create a class interval. Okay, so say first data is going to minus so this, the second data is going to be this, plus suppose I want to make a class interval of 0.02% return, 0.02. So this is the second return. Similarly, I'm going to keep it increasing till I reach here. So still I'm 0.05, I want 0.08. So we can delete these two. Yeah, so this is our bin, what we actually need, the class interval, the how many times we are going to get return of minus 0.12, how many times we are going to get the return of minus 0.1098. Similarly, it will actually return the frequency when we will calculate the histogram. So now let's create histogram. Data, data analysis, histogram. We need to select the data range. So first let's select this only, and then we have to put bin range. So we have created our bin, and we want it on the new sheet. We want chart as output as well. Yeah, so this is the frequency and this is the chat. So you can see that we are getting highest return. I mean, we got 0.010 return at the maximum number of time. So basically Nifty returns us 1% daily return for the maximum number of time, and after that there's negative, and we can see very little. So if we see this data carefully, we can see here some normal distribution kind of shape. Most of the data are actually normally distributed. So this is how we will create the histogram. Now the last thing which we are left with is the regression. So first let's try to understand what regression actually is and why do we use it. So suppose I went to a suppose I went to a cafe and there I got a bill of $100. Okay, and I prefer to give a tip of $12. Okay, similarly if I go and get a bill of $200, so I will prefer to give a tip of 22. If I'm going to give 300, then maybe 32, 400, then 42. So I think everybody will be able to say that what if I'm going to get the bill of 500, right? That will be 52, right? Obviously, suppose the waiter have all these experience and now he got 500, so he can make a calculation from the past experience that okay, I am going to get $52 this time. So here data are actually very smoothly, distributed. So we can similarly simply say that if any customer is coming and getting a bill of $100, so he is going to give me $10 plus 2, right? If $220 plus 2, okay, sorry, here it's 2. So everywhere he is going to give 2 extra, right? And the 10% of the bill plus 2 extra. So we can actually create an equation over here that will be A plus bx. Okay, so this is basically a kind of regression or best fit line equation. Okay, so A is what? The 2, that is, even if you are going to get, if there's no bill, okay, even then you can suppose that you can get 2, but yeah, theoretically it's not true, but yeah, it's something like in a statistic it's called intercept. Okay, and this 10 is the part of the total bill, that is 10%. So here B is going to be 100, sorry, X is going to be 100, and 0.10 will going to be the B. So 2 plus, suppose 0.10 multiplied by the total bill, say 100 rupees or maybe 500, say. Sorry, I just forgot to put the equal sign over here. Yeah, so it's 52, right? So we have make actually equation which help us to predict what amount I'm going to get when I'm going to get 500 as a bill, right? So this is what actually regression do. So here it is very simple data and very small data, so we can make the this equation manually. But when there's large set of data, we need machine to do that, and that's what we are going to do here right now. So again, going to data analysis, regression. So how I'm going to analyze this data? So for example, I assume that tomorrow Nifty is going to go 5% towards upside. Okay, so I want to predict what will be the change in ITC price. Okay, so here I want to guess or predict the return of ITC for tomorrow. Okay, on the basis of Nifty. Okay, how Nifty will move, on the basis of that I am going to predict the ITC price. So here the price of ITC is going to be dependent on price of Nifty. So Y will be the dependent variable, X will be independent variable. So in this case, X will be Nifty price or Nifty return, whereas Y will be ITC price of ITC return. So for Y, I am going to select this one, and for X, I am going to select. Don't get confused. Either you're going to take it from up or down, it will give the same result. And then I need line fit plot. Yeah, all done. Yeah, so here we can see the same equation. So this is the intercept, which in our example case 2 was the intercept. So this particular is intercept that will be added, and this is the coefficient that will be added, that is multiplied to 100 in our case, right? So B, X is what? The Nifty return. So here we can say the equation is this plus Nifty return multiplied by this coefficient. So we will be able to predict the price for tomorrow if we know that what is the possibility that Nifty will go 5% high. Okay, so and best fit line is what? We can see this line. So we can see that there's positive correlation between ITC and Nifty. This line suggests that. Okay, so we can also get the equation for this line, which we have done yesterday. Let's quickly see how to get the equation. So from insert, if we are going to get the scatter diagram for the yeah, so this is the kind of data, and now I want to add line and the equation to it. So we can do it from here. Yeah, so see, this is the equation we have here, the regression equation, and this is the line which we were getting in the last graph also. Okay, and r square is basically suggest how good this best fit line. So if it is very good to predict the model, for example, if I can be, if suppose this r square value is going to be 1, it's clearly mean that if I am going to predict the value for tomorrow on based on this equation, then that will be 100% accurate. Okay, and if it is 0, if r square is going to be 0, it means that this model will not work for prediction. It is going to give a strong prediction. So here the value is very low, that is 0.3 or 0.29. So this model or this regression equation will not give us a very strong or accurate prediction for tomorrow price on basis of Nifty movement. Okay, so we may look for some another model which we can learn in some other statistics session. Okay, but in regression model, this is not fit enough to go with this model to predict the price of ITC. So I hope I made it clear, my statistics session. Anything else you want to ask, or we can wind the class over here. If any confusion, you can ask me by unmuting you audio. Otherwise, we are done for today. If any point you want me to go through once again, I can do that. Okay, then let's close the session for today. I'm signing off. And okay, then thank you.